Vijay Tolani. I am a cloud solutions engineer with RightScale. Today what we'll be talking about is some tips and tricks for how to run a successful proof of concept. One of the things that I focus on at RightScale is really helping the enterprises adopt cloud computing. And with that particular market segment, we end up very, very focused on talking about enterprise applications and private clouds. And specifically with these types of markets, we have conventional ways about going out and evaluating tools, going through proofs of concepts. And we've seen a lot of those be successful. And some of those go through some challenges in taking kind of their conventional approaches and applying that to cloud computing, being the paradigm shift that it is. So I've been through a number of these proof of concepts and wanted to share some of the experiences that I had, the lessons learned, so that you guys can all learn from those and that we can be more successful with our projects moving forward. So let's keep this as an open session. We have a mic which we'll pass around. If there's any questions or comments that come up throughout the course of the presentation, feel free to interrupt me, and we'll take things from there. In terms of the actual agenda that we have of the content prepared here, we'll start with just kind of a high level of the state of the cloud, where we are and how we've conventionally selected these types of infrastructure management tools, and how that translates into this cloud paradigm that we're working with. Then we'll walk through some best practices on cloud POCs and the recommended approach for handling these POCs. We'll specifically talk about how to choose the appropriate cloud and choose the appropriate application for those proof of concept environments when you're selecting the particular tools that you want to work with. Then we'll walk through, as you come across some of these technical challenges, how you can overcome some of those challenges, and really, when you get to the end of your POC, how you measure success, how you can elaborate or define that success criteria and measure whether your POC was successful or not. So if we start at just kind of a high level of saying, how have we, in a conventional fashion, evaluated vendors? What process and techniques did we go through to say, hey, this is the vendor that I want to work with. This is the vendor list that I want to bring in for a proof of concept. It really started with having, a steering committee that's looking at the requirements that the business has and translating those down into a set of technical requirements. From there, maybe you started with a set of analyst reports and say, hey, I'm looking for an infrastructure management tool. Who are the vendors out there? Who should I be talking to? Who are people within the industry out, using? And then maybe you go and you say, all right, I'll take that list that I've gotten from one of the analysts, and now I'll go out and I'll issue out an RFP, and I'll get responses to that RFP. And if they go and these vendors actually meet the requirements that my steering committee came up with, well, then we'll go into a proof of concept and take a look at those particular vendors. So this may not match what every organization has, but it's an example of the type of approach that I've seen in the past from my experience working in enterprise IT. What is really interesting is when we start taking this paradigm and we apply that to where we are within the cloud today, in that we live in an on-demand world, right? We're used to the devices that we work with in our personal lives. We're used to our iPhones and our iPads and this self-service on-demand type of a world. Our end users are expecting things to be instant on. Our end users are expecting to go to a self-service portal and request access to what they're looking for. And ultimately, IT is being asked to operate at an unprecedented scale. There are now more apps than there ever have been before. There's more data than there ever has been before. And people are expecting it quicker, faster, and more reliable than they ever have in the past. And when we're working with this set of expectations, it ultimately changes what we're looking at. When you then look at the technology that we can use to actually fulfill those expectations, this market is evolving unbelievably quickly. So for those of you who attended the keynote this morning, this is a slide that Michael used, just showing in the last year what has happened. So you say, all right, I normally went through this process. I went through this 6-month steering committee, a multi-month evaluation process, and I went through these POCs. Well, while I was doing that, what happened? Well, guess what? The cloud landscape evolved so significantly in that time that it can actually go and make that entire process you went through completely irrelevant. You started out looking at an analyst report that maybe was, a couple months dated. And then you went through a couple-month evaluation process and a couple-month POC, and by the end of it, the solution that you were looking for may be out in the market, but it wasn't available when you started your process. And it's just requiring a new level of agility within our evaluation and proof of concept process, which is what I'm going to walk you through during this presentation today. So if you're not careful, you find yourself going through and saying, well, this is my process for evaluating vendors. This is how I go about selecting a vendor. And I have my steering committee, and they determine requirements. But hey, guess what? Things were moving so quickly that by the time they actually get those requirements found and documented, well, they changed a little bit. And you say, hey, I went out and I read some analyst reports. Well, analysts do a great job of giving us a point-in-time snapshot. But if something was just released yesterday, it's probably not in an analyst report. And maybe that's the right solution for you, and the analyst report you were looking at was a couple months dated. So now you're looking at somewhat dated information. Then you go and you take your conventional methodologies of RFPs and you're asking the questions you always have, but oftentimes these RFPs that come our way are asking such specific questions that they don't really apply. They're asking us for things in the conventional way that we've approached them. So they're asking for things like it's a specific feature of this is how I handle change management, or this is how I handle high availability, and the RFP is written in a fashion that it's almost impossible to answer in a cloud paradigm, because oftentimes we're taking different technologies and different approaches to solving the same problems. And when we go through this POC phase, oftentimes people are actually choosing their most complex applications and their most complex environments and saying, if it works for this most complex thing, well then it'll work for anything. And that's the way we've kind of historically evaluated products, whereas where we are in the phase and the maturity of cloud computing is it's really working the other way. It's starting with the simplest applications and then working its way on up. So if you start with that most complex application and your POC fails, well, you didn't tell yourself anything. So we'll walk through a very different approach in terms of how you can approach those evaluations and those POCs. So with that, we'll go ahead and jump right into it. So when we start talking about how we can evaluate our vendors and our approach to this, it starts with making it a learning experience and really taking an agile approach. Taking it stepwise, step by step. It's not something that you do once, but let's try something, let's see if it works, let's learn from that, and then let's iterate on it from there. So if any of you are familiar with agile software development, you'll see a lot of the similar methodologies here with what I'm talking about. When you think about cloud as a whole, really what it's delivering to you is agility back towards IT. So taking an agile methodology towards our evaluation makes a lot of sense here. When we talk about the approach itself, we want to start with something simple and keep it lightweight. Because the market is evolving so quickly, if your POC and your evaluation takes more than a month or two, quite frankly, the data that you're coming out with is irrelevant. So it has to be something that's really, really quick. And after you get through that initial phase, you can continue on the next phase and the next phase and the next phase. But if it's something that takes more than a couple months, you're going to be evaluating vendors that are potentially no longer relevant, and there's more applicable solutions out there available in the market. The other thing is something I talked about earlier, which was historically we've gone and we said, hey, let's start with the most complex environment, and we know that if it works there, it'll work anywhere. Well, what I'd actually encourage you to do here is take the fundamental opposite approach. Why don't you start with something very simple and prove that it works for something very simple, and then get more complex as things go from there. So start with simplicity, see success, and then get more complex to find where that barrier is and what's ready for the cloud and what may not be ready for the cloud. And ultimately, you get to this approach where you're getting more and more and more complex until you find that ceiling of what can run on the cloud and what may not be ready at that point in time. The other thing is you should really think about the entire life cycle of that application. So it's not just getting this application up and running once, but think about the entire life cycle of it. Not just provisioning, but how am I going to manage this? How is it going to handle high availability? How is it going to scale? How am I going to decommission? When this application is no longer relevant, am I still using the same amount of infrastructure, or does it scale down to handle that? So with that, the next phase after we get through that approach of saying, hey, this is the methodology that I want to take, is really choosing the cloud. And one of the biggest things that we come across here is specifically a lot of customers and specifically enterprises want to build private clouds. And there are very real reasons why they want to build private clouds. Oftentimes they're looking for the flexibility of being able to define their own instance types or choose their own hardware, whether it be SSDs running in the machines or GPUs or high-performance storage subsystems or high-performance networking. There's very real reasons why they would want to use a private cloud. Maybe they're subject to specific compliance regulations and they need to keep that behind a corporate firewall. Or they're, from a finance perspective, they're used to a CapEx model. And this model in the public cloud of saying, hey, it scales up and it scales down and it's pay per use, just doesn't make sense from a business perspective. There are very, very real reasons why they may want to use a private cloud. But one of the things that a lot of customers struggle with is realizing that the public clouds and the private clouds are built on the exact same technologies. So when they start going through these proof of concepts, they say, all right, step one is go out and build a cloud. And then they go and they get caught up in all of this process. And they start thinking, okay, well, I need hardware. I need to choose an orchestration software. I need to build all of these things. I need to procure it. I need people to manage it. I need to do all these things. And very quickly, this proof of concept just stagnates. It becomes this big project, and it doesn't go anywhere. What's really interesting is when you think about it from a RightScale perspective, is RightScale is designed to run on both public and private clouds. So let's say you want to build a private cloud based on OpenStack. Well, we can absolutely build a private cloud, get that up and running using OpenStack, but we've also integrated with the Rackspace public cloud, and that's running OpenStack as well. So if you want to know, can this application run on a cloud, well, why go through that entire process of building that cloud first if there's a chance that the application will fail? Why not start with seeing if that application can actually run on the Rackspace public cloud that's based on OpenStack? And if it is, then you say, all right, now this can run on a cloud. Then from there, maybe you say, can it run on my private cloud? And you can start taking it in that sort of a stepwise function, because otherwise you go through that process and you say, hey, I built a whole private cloud. I've got this whole thing running. Spent 6 months doing that, only to find out that now, first of all, I'm running a version of OpenStack that's 6 months old. And second of all, I found my applications don't run there. Well, why did I waste 6 months building that cloud? Why didn't I find that out much earlier by starting on the public cloud? It's really interesting. RightScale takes this approach oftentimes because we publish server templates and integrate with clouds. And when we're building a new cloud and integrating that into RightScale, oftentimes we'll do that work in parallel. We'll start running on another public cloud. We'll start developing our server templates, seeing if applications run there on an OpenStack-based cloud. And at the same time, we're building our integration into that cloud on that data plane. So this sort of a methodology gives you a really different approach to it. So the way I'd summarize it is, it's a marathon, not a sprint. And a lot of times people go and they get into this fantasy, if you will, of what I really want to do is I want to be here. This is my end goal. This is where I want to get to. Let me get there as quickly as possible. And what I encourage you to do is take a very different approach and actually say, okay, it's going to be a journey for me to get there. Why don't I start with the smallest chunk that I can take off, see if that works, and then take it stepwise from there. So if you try to jump straight to that end goal, oftentimes it's too much at once. It's too much of a paradigm shift. And you just get caught up in the process of going through all these various things, and you don't see any success along the way. So we encourage you to go and start with something small, see that work, and then get more and more complex from there. From there, we get into, great, I have a cloud that's up and running. Now I need an application. I need to see what can actually run on this environment so that I can see if it applies to the portfolio of apps that I have within my company. And that's when we say, all right, how do I choose an app? The phrase we've been using at RightScale for a while is clouds that fit for everyone, but not for every application. Everyone has an application that makes sense to run on a cloud, but that doesn't mean that every application that you run is a good fit to run on cloud infrastructure. And I'll walk you through some of the specifics here of what would make a good candidate application for that proof of concept. First things first here is a lot of times when people are choosing apps for their proof of concept, they just kind of make one up. And they say, hey, I manage the infrastructure team here. I don't know a lot about the application. Let's just pick one. That works, but what's a preferable method is if you actually have a new project that's coming up and you can say, hey, why don't I take this as an example and let's see if it works for this specific application. That way you know that it's a very real application, it's a very tangible workload, you have a very specific success criteria on whether that works or not, and guess what? If your POC is successful, well now you already have the framework and you know how you can deploy that specific application, and you can say, all right, it works for this type of application, what other apps do I have that are similar to that? What other things could I deploy on this cloud infrastructure? And then you can kind of take things from there. So pick a real application, start with real expectations, and start with the simplest ones. Prior to joining RightScale, I was a data center architect with Cisco Systems, and I helped customers go through that transition from physical servers to virtual servers. And you look at the way we approached that, and it was exactly that. We started off with, file servers and domain controllers and really simple stuff. And eventually, after the technology matured and we got more comfortable with it, only then did we start taking, more advanced applications. We started taking the exchanges and SharePoints of the world and started migrating those from physical to virtual servers. Now we're doing the same sort of thing with cloud, is we're starting with the simplest applications and the simplest workloads, rather than starting with that, extremely complex one, and then we're getting more and more complex up to there. The other thing is, keep in mind really what we're solving with cloud. A lot of people go out and they say, hey, I just want to build a cloud because that's what everyone else is doing. And I want to take all of my applications and I want to migrate them to the cloud. What I would encourage you to think about is, what are the real benefits that cloud is giving you? What is the problem that you're solving? And let's pick an application that makes a lot of sense that can really benefit from this cloud infrastructure. So as an example, a couple of the specific benefits that we see from cloud is it's very quick to deploy, it's highly scalable, and for those apps that have a highly variable workload, whether it's a marketing campaign, it's a time-sensitive workload, it's a public-facing web application that sees spikes in traffic, whatever it may be, pick an app that benefits from cloud infrastructure and start there rather than just migrating to the cloud for the sake of saying it's running on a cloud. So here are a couple of apps as an example that just about every organization has one of these somewhere, and they tend to be good fits. So web applications, mobile and social apps work really, really well on cloud infrastructure. They're public facing. They tend to have very dynamic workloads. They tend to use open source lightweight technologies, which work very well on cloud infrastructure. Then you have, the big data processing and the batch processing. Those tend to be very good fits as well because they have that highly dynamic scale up, scale down type environments. You say, hey, why run this job on one node for 100 hours when I can run it on 100 nodes and get that job done in 1 hour? That makes a lot of sense on the cloud where you have that sort of dynamic capability to spin up and spin down servers on demand. And you start looking at the life cycle of the applications and you say, hey, development and test. That's a great environment to start out on a cloud, right? These workloads are by their very nature transient. A developer goes and they say, hey, I just developed this new app. I need to go out and test it. I need to test it. I test it for an hour. I test it for a day. I test it for a week, whatever it may be. After that's done, well, then there's no reason to have that server up and running. I'm back to writing code. So it's that transient sort of workload that makes a lot of sense to run on cloud infrastructure. So when you're choosing that application, choose a specific app that's going to benefit from running on the cloud rather than just saying, hey, I moved this to the cloud, congratulations. The other big thing, and this is one that's particularly challenging for folks that have been through the physical to virtual transition, is a lot of times you think of an infrastructure as a service cloud, and because it's based on the same sorts of technologies we've been working with for a while. It's based on x86 server hardware running on hypervisors that we know relatively well. We say, hey, well, isn't this infrastructure as a service cloud just the same thing as my data center? It's just a shared resource. It's just my data center in the sky. Well, when you actually start thinking about what these clouds are made of, they're very, very different than that. And a lot of people go through this process of saying, hey, why can't I just take this machine image that I can launch onto my private virtualization environment? Why can't I just go and move it up to the cloud? When the truth of the matter is the way that these clouds are architected is fundamentally different. You look at things like as simple as networking. Say, when I provision servers inside of my physical data center, I had a static IP address that server was launched on, and that IP address never changed. And I had so much availability built into the underlying infrastructure that the application itself didn't have a lot of intelligence in terms of high availability. It assumed that when it was running on a server, that server had redundant network connections, redundant power supplies, redundant power grids connected to that. All of that intelligence was built into the underlying hardware. It was very high-performant hardware, high-performant networking, high-performance storage that I was running on. And when you start getting up the stack to the application, it just kind of said, I assume that the infrastructure is going to run. I don't even think about it. Cloud's fundamentally different. Quite frankly, it's the complete opposite of that. Now we start working and we say, all right, I'm running on this infrastructure. It's commodity infrastructure. That's the point of what I'm actually trying to accomplish here, is I don't want to have to build that super highly available, ultra expensive hardware. I want to be able to run it on any hardware, whether it's my own hardware inside of my data center or a public cloud provider. And we make that basic assumption that that infrastructure may fail at any point in time. We assume that it will fail, and we start building the intelligence on top of that. Now you start leveraging tools like RightScale that can go out and say, provide you with the level of automation that if the infrastructure fails, the application is aware of it, and the application can tolerate that failure and keep on running. But now we start getting up to those hardware, well, now I see, is it going to achieve the performance levels that I need? And when I launched it on the public cloud, I wasn't testing for security because I knew it wasn't going to run there. I knew that it had to run behind my corporate firewall. And now that it's running on my private cloud, now I can test for security and compliance. Or, my existing processes. I didn't worry about, directory services. I didn't worry about Active Directory when it was running on the public cloud. But now it's running inside of my data center, and now I start thinking about those things. A lot of people will take these types of considerations, and they'll get caught up in their POCs thinking about security and compliance, and then they go through it, and they're like, well, the app doesn't run. I spent so much time thinking about security and compliance only to find out it didn't run. Well, make sure that it runs, see some success from there, and then start thinking about some of those things. So I'm not saying forget about them, just take it in that sort of an iterative approach, getting from the simplest type workload to the more complex from there. Specifically, we come across a couple of specific ones that I wanted to highlight for you of the types of hurdles we come across and how we've worked around some of them. The biggest challenge that we've seen on cloud infrastructure as a whole is around storage. So specifically, if you look at AWS and the challenges that we've seen with EBS, it's getting better and better every day. Things like provisioned IOPS help significantly. But as we start going and saying, hey, I want to run this application, it's a high-performance database, it used to run on this big, bad, beefy physical box, now I want to run it on a virtual machine out in AWS, well, that can be challenging. So then we go and we develop this set of best practices and say, hey, I can have multiple volumes and I can stripe across those volumes and get a higher performance level. Or maybe you say, all right, I've gotten as far as one instance can take me. Now can I leverage a database architecture where I'm actually horizontally scaling my database via sharding? Right? I hadn't considered that in the past. I'd just thrown hardware at the problem, but maybe I can shard this database and get a higher performance level from it. We have a whole set of partners that can work with you and help enable those sorts of applications to be shard aware and handle that sort of thing. Or historically, I've always used a SQL database, but you know what? With what I'm storing here, there's no need for that sort of relational capability. Maybe a NoSQL database can get the job done. And NoSQL databases, by their very nature, are designed to horizontally scale. They're designed to run on commodity hardware, and they just work better in the cloud. So when you get to that sort of a storage challenge in terms of the performance, you can start thinking about some of those things. And as we talked about earlier, naturally, if you're building your private cloud, you have the ability to leverage any storage you like, and you can put that sort of higher performance storage in place. Another thing we come across very, very often is a need for shared storage. So the way most infrastructure as a service clouds operate, you can take a single volume and you can mount that volume to an instance, but you can't have a shared volume that's mounted to two instances at the same time. Most clouds offer you some level of object storage, so if you're just sharing files and whatnot, you can put those out in that object store and they can share from there. But if the application itself is written in a fashion that it's expecting, a shared NFS mount, or it's expecting a shared LUN out on a storage subsystem out there, well, then that can be challenging. So we've, built a server template for OpenNFS. You can leverage a cloud instance and provision OpenNFS, and then now you have that sort of a shared environment where now you can have an NFS mount mounted to multiple instances at the same time, and you get that sort of a shared storage environment when working on a cloud that doesn't support that natively. One of the other fundamental challenges that we see over and over again is licensing. A lot of legacy applications are licensed in a model that isn't very fit for cloud infrastructure. It's licensed based on the number of cores or the amount of RAM inside of an instance. And you start looking at a cloud and say, all right, I've built this out with RightScale to your best practices. I'm leveraging auto-scaling. I'm dynamically spinning up and spinning down servers. Well, how many cores do I have? I had 2 instances running 1 hour, and I had 100 instances running the next hour. Well, I don't know how many licenses that is. The licensing model doesn't make a lot of sense there. RightScale solving that problem for you via our multi-cloud marketplace, in that we have relationships with a number of independent software vendors who will actually go and publish server templates on their behalf. So rather than just going and giving you access to the software and giving you instructions on how to go and download and install that software, they're actually automating the installation process, publishing it for you so that it's installed properly each and every time, as well as it includes a licensing model that makes sense in the cloud. It's a licensing model that's based on the size of instance and how long it's running, so that it makes sense to run that on a cloud where it's a dynamic environment and it's scaling up and scaling down. The biggest area where we see challenges right now outside of storage that we talked about earlier is actually network flexibility. I talked a little bit about this earlier in terms of IP address assignment, in that we're used to having static IP addresses, and now we move into the cloud where it's dynamically assigned IP addresses by default at least. A lot of times we can get around these sorts of limitations via little tricks with DNS. So things like, if you guys are familiar with the application server templates that we publish and our databases and how they register together, We oftentimes will say, all right, this app server needs to register with my master database. Well, how do I know the IP address of my master database? Well, what we'll do, instead of hard coding an IP address in that application, is we'll actually leverage dynamic DNS. When we provision that master database, it leverages a dynamic DNS provider, it updates that DNS record with its new IP address. If we go and we promote a slave up to master, well, there's a script incorporated with that, which is going to reach back out to that same DNS provider and update that DNSA record. At that point, when that app server goes and it says, and it runs that script, connect to database, it resolves that DNS hostname, and now it's always pointed to that master server. So you can get around some of these tricks with just clever use of DNS. And when we get to the security and compliance aspect, of course, if you design an application to work in the most hostile of environments, if you design this application to work on a public cloud, you say, if this were to run out in this sort of a shared environment, what would I have to do to make it secure and compliant? Say, all right, I need to encrypt data at rest on all the volumes. I need to put traffic through a VPN tunnel so it's encrypted in transit. Whatever it may be, if you design for that sort of environment and then you move to a private cloud, well, you know that it's going to be secure in that sort of environment as well. So with that, we'll transition to really, as you've gone through this POC, how you would define success and what the ideal metrics are. So the specific metrics are going to vary by organization and what specifically you're looking to accomplish. But here are some very common ones that we come across. And really, with any POC, you should start by defining that success criteria and tracking against those. And say, hey, am I meeting the criteria that the business said we were looking to accomplish? The first and most relevant one is agility. And the biggest thing that we've seen cloud help organizations with is now enabling IT to respond to those business needs very, very quickly. And that's one of the key things you should be measuring. Organizations oftentimes have seen provisioning times of their end users waiting multiple weeks or multiple months for access to resources. When I built this sort of a cloud environment, what's the impact to my end users? Can I now get them access to things in minutes instead of weeks or months? And what does that mean to my business? Historically, if I haven't been able to deliver that level of agility, we've seen rogue public cloud use. We've seen shadow IT. People going out around IT and leveraging public cloud servers. And now IT didn't know it was out there, certainly wasn't secure, probably was a compliance hindrance, and it was a significant challenge from a business perspective. So let's take a look and see what we're delivering from an agility perspective. Let's also take a look and say, hey, what can I actually do with this? What if actually going through this cloud project, I can now take what was in the core competency of IT and give some control out to the developers and the lines of business owners? What if I could take some of the things that my operations team was doing and I can automate it? I can make my ops team more productive now. Maybe now they can take on those new projects, which can now have an impact on the business. Other things that were stuck in that queue, they were stuck doing the day-to-day aspects of keeping the lights on. Now they can go out and actually go through projects that deliver business value. I mean, historically, I was limited to the specific regions of the world where I had physical data centers available. Now I've expanded my global footprint. And the business now wants to go and expand to a new country. Well, now I can leverage a public cloud in that environment, and I can go and actually fulfill that demand to the business, letting them go out and make that key acquisition. What am I actually delivering to the business? Maybe I can scale up or scale down to meet demand. Maybe I can launch new applications quicker that I wasn't able to before. Metric number 2 is around efficiency. And basically saying, what does this mean from a time and money perspective? How much is this actually going to save me? Here I start thinking about, okay, if I'm leveraging a public cloud, how much does that cost me? And if I'm leveraging a private cloud, how much does that cost to run inside of my data center? Okay, well, those are two very different models from a purchasing perspective. Is this a capital expenditure or an operational expenditure? What am I actually looking to accomplish here? Think about it from an opportunity cost perspective, right? If my team is now spending their time focused on these automation aspects, and I'm building this sort of a self-service model, what else can they be doing with their time that they would historically spend on provisioning and managing these physical servers? And think about it from an actual application deployment perspective. If you want to roll out a new application, what's the time from when you say, this is what I want to do, to when it's actually up and running? How much time do you spend planning and preparing for that? How much time do you spend deploying that application? And subsequently, how much time do you spend actually going and managing it? And ultimately, when we look at failure and success, it's the end user that determines it. It's those developers, it's those lines of business owners, it's anyone out there that's consuming the services from IT that we're giving them and saying, if I'm meeting their demands more adequately, then it's a better solution that we're bringing to market that meets our customers' needs. So there's this whole new web of applications out there, these Web 2.0 scale-out architectures, the new web app that people want to push out, the new social presence that every company is driving for, the mobile applications that people want. You want to launch a game, or you will have access to a whole bunch of data that you want to process and make a business decision from. These things that IT historically maybe didn't have time to get to, now maybe you can access them and fulfill those requests via having this sort of a cloud architecture. Or how can I support things now that are, geographically available across the world, that are maybe can scale out or be more highly available than was possible before? There's all sorts of things that we can do here. These are some examples, but every organization is a little bit different. This is just the commonalities that we've started to see. So to sum this up for you, what I'd recommend is starting with an application that's real, and start with an application that makes a lot of sense on the cloud. Something lightweight, something public-facing, leveraging open source tools if possible so you don't have to deal with those licensing challenges. Second is treat your evaluation and your POC as a learning experience. Don't put out a set of criteria that you know is likely to fail. Start with something that's likely to succeed, and then iterate from there, getting more and more complex to figure out how mature cloud is and how much you can actually solve with it. Don't go through that process initially of building a private cloud. Start with seeing if that application can run on a public cloud. Choose one that's leveraging the same sort of orchestration technologies. We have public clouds that run with both CloudStack and OpenStack, which are the same technologies that we use for running our private clouds. And you can start with those, see if they run there, and then go through that process of actually building that private cloud behind the four walls of your data center and behind your corporate firewall. And when you think of it, don't think of the cloud as a data center in the sky. Think of the different architectures there and choose applications that make sense for that architecture. And when you're measuring success, consider things like the agility, efficiency, and better solutions that you're delivering to your end users. And of course, you're not alone in this. We're here to help. We have a whole team here at RightScale that as you're going through these sorts of plans, when you're saying, hey, I want to develop a cloud strategy, I want to pick the right applications, I want to go through this proof of concept. We have a team at RightScale that has done this for years now. We have a wealth of experience that we're here to help you with. So let us know how we can help. We're here to help you in any of these aspects, whether it's guidance on your strategy and how you should be moving forward, or actually helping you with executing with that POC. So with that, I'll open it up for any questions. Anything's on the table? I think we've got a mic which we'll pass around here. There's a question right here.
You mentioned something about automating operations. I wonder if you could give an example of something that fits that.
Sure. What we see very often is, let's start with just the aspect of provisioning a server. In that, historically, what you do is you'd have Joe sysadmin say, hey, I want to deploy this web server. Joe, can you go out and deploy it? He'd go, he'd start from a machine image, he'd provision that server, then he'd go and he'd start configuring it. And he'd configure that server, and he'd get to the point, he'd say, all right, here you go, it's up and running. Maybe it took him a few days to do that. Well then, that's great, but what happens when something goes wrong with that server, right? What happens if it's 2 a.m. on a Saturday and Joe's on vacation? Well, who can go in and troubleshoot that system? Well, someone else can go in and try to figure it out, but Joe's the only one that really knows what's happening there. When you start leveraging RightScale, what you're doing is taking that process that Joe would go through and automating it. Starting with a base image and then a set of scripts that are actually going to go through that provisioning process in an automated fashion. So now, first of all, the system itself is self-documenting. So anyone that knows the system can go in there and see what was happening. Second of all, you have a set of monitoring that's built in there and a set of alerts that'll trigger you and let you know something goes wrong. And you can even automate the remediation of some of those challenges. So now you think about it, and the role that Joe plays in your organization is much more significant. Now instead of doing something once, he's actually taking the time to think about what's the best way I can do this, and how can I automate it, and how can I spend my time on those types of things rather than those repeatable, mundane things and just doing the same thing over and over again. Does that make sense?
Yeah.
Cool. So another question back here?
Yeah, that fits in if you're taking the application to the cloud. But what about if you have a private cloud, your own internal, you know, I mean, how does that play into that? I mean, I didn't get that, you know, I mean, how would that work?
Sure. That's the beauty of working with RightScale is it's the same exact thing. So whether you're deploying onto a public cloud or a private cloud, the methodology is really the same. The underlying infrastructure is very different. But in terms of how you actually deploy, manage, and operate those virtual machines once they're up and running, it's the same exact experience. We've seen that over and over with our customers where they start out on a public cloud, and that's sort of an OpEx scale up, scale down model, makes a lot of sense, and they grow out of it. They want to see a CapEx model. It makes more sense from an economic perspective or a performance perspective, or vice versa. They start out running on their private cloud, and they leverage a public cloud for disaster recovery or capacity planning. When they're out of capacity, they leverage a public cloud. You have the ability to go back and forth, and it's the same exact configuration framework and methodologies around both resources.
What about if it's a high-end server, like you said, you know, it's a customized server, there's no VM technology there, correct? So, I mean, how would you do a physical server, which you have brought it up?
Sure. Yeah, so in terms of the actual physical hardware, that problem is one that still exists, right? If you have a power supply that goes out in a machine, the power supply needs to be replaced, right? That continues to exist. The difference here is, historically, you've deployed this application to that single server, and it could only run there. What I've done now is automated the process of provisioning that server. So if something goes wrong, instead of going and changing that power supply, I relaunch that server. It provisions a new server with running that application, flips over DNS, sends all of the traffic there, and now when you have time, you can go in and repair that box, but the application isn't tied to that physical hardware anymore. Does that make sense?
Yeah.
Other questions? Questions, comments, concerns? All right, well, we'll go ahead and wrap it up. I've got a set of business cards up here. Feel free to come in and grab one, or if you have any questions that you were shy to ask about, I think we've got a few minutes left, so I'm happy to take anything one off. Just come on by. Thank you much, everybody.